subject of pretty much the entire second half of the year, but we still got to get there. Expected value is more of a word problem-y sort of probability distribution, but really you're just looking for the mean of the probability distribution. We'll also play around with standard deviations with this just to get a sense, but we talk about games of chance a lot when it comes to expected value because it's very relatable, but you could also throw in other ideas. We'll talk about life insurance policies and things like that. Those end up being pretty interesting because, like if you win in a game of chance, it's pretty obvious what winning is. Like you succeeded and you got some money for it. In a life insurance policy, you win if you get money. But how do you get money? You die. So did you really win?
No.
Somebody won, just not you.
Your own death.
Right, well there's that. But how do you collect it?
You have like a surrogate.
Yeah, you gotta have a shell corporation, some dummy bank accounts and all that stuff. It's gotta be well thought out.
So you used the word surrogate wrong, and that's.
Why do I get this feeling that you put way too much time thinking about
That's what they were saying.
Honestly, if at some point you don't start thinking about that kind of stuff, then I feel like you're probably not going about life the right way. So whether or not you actually act upon it is probably what defines you as either a good person or a not so good person. But like the part where you throw your creative juices towards something that may be a little outside the box, that's how you're going to succeed if you're going to succeed. All right. So New York State, like all the schemers, the people who have all these ideas for new business ventures and stuff like that, it's because they're sitting there thinking about all this stuff. Doesn't always work, but at least they're in the game. All right. So. And then if it doesn't work, they just fake their own deaths and collect on the life. So we got it all figured. So New York State daily number, your goal is to select the same 3-digit number that the computer selects. For straight play, the payout is for a $1 bet is $500 for the winning 3-digit number. So we want to determine the expected value for this game and what it means. So we're going to win or we're going to lose, and each one of those outcomes is going to correspond to a dollar amount. If I lose, it's pretty obvious. How much do I lose if I lose?
$1.
$1, yeah. Minus $1. All right. Now, there's a little gray area when it comes to winning because it depends on whether or not you get your wager back. All right. In casino games of chance, you get your wager back. Not in not every lottery is that the case. All right. So if there are certain lotteries where you get your wager back, but there are plenty of them where you don't. All right. So we're going to assume you do not get wager back. All right. This may sound dumb, but I'm just going to say it. Wager is just another word for bet. All right. So if that's the case and I win this lottery, how much do I win? $499. All right, what's the probability of winning? 1 in 1,000. Probability of losing? Everything else. So for these kind of problems, we want to find the mean by hand, x times p of x, just because you'll figure it out quicker than even typing this into your calculator. So 499 over 1,000.
Wait, sorry, how did we know that it was 1,000?
1 over 10 possible.
Three-digit numbers, yeah. So we're going to get negative 500 over 1,000, and we'll talk tomorrow about what that means. But in dollars and cents, that's the same as negative 50 cents.
To the office, Claudia at
All right. So we'll discuss in more detail what that means, but that's the skill associated with figuring out expected value. We're at the point now where we have to interpret what that means. All right, the stock statement that we always write for this is that for each $1 bet, in the long run, we expect to lose 50 cents. All right. So that's what you write as an answer to the question of what it means, but it doesn't always really kind of tell the entire story, because there's no way to lose 50 cents. If you make a $1 bet and you lose $1. If you win 499 net dollars. All right, so it's really a matter of, well, where did this, or how does this 0.5 factor in? It's an average value, right? And but what it is actually a limit of an average value. So it's telling us that if you had infinitely many people playing this game infinitely many times, if you were to take all the wins and losses and average them together, you would end up with negative 0.5. All right. So that's, when all is said and done, at the end of time, that's what the amount would be that you would have lost. All right. The minus sign is indicating a loss. If it were positive, it would be a gain. All right. So what that's telling us is that the game is not in favor of the player. All right. So the game is not. So we would just say the game is not favorable. All right. However, in the short term, it might be very favorable. Right. So if you win, you buy one lottery ticket and you win the one time, then you brought in almost 500 times what you wagered. So I mean, that's great. The issue is that the more you play it, the more you're going to approach the expected value, all right, the mean of the probability distribution. All right, so the law of large numbers is at work here, that this would be trending towards negative 0.5. All right, so this is the technique that we use to make a determination of whether or not a game is fair in the long run. All right, so if you're thinking of any kind of game of chance, a casino game, or if you're thinking of a lottery, or you're thinking of the games that you're generating for the project, expected value is a great approach for determining whether or not a game is fair. If you get an expected value of 0, completely fair. Positive, it means it's in the favor of the player. Right? Negative means it's not in the favor of the player. Right? What the casinos do, they have games, roulette, craps, card games, so you have blackjack and things like that. The probabilities are such that the expected value is close enough to 0 to entice the player to play, right? So you have enough of a chance of winning that you're willing to wager your money. All the house needs is it to be slightly in their favor, right? It doesn't have to be very much in their favor. They just need it to be slightly in their favor, because you look at it on an individual level. They look at it on a global level, right? So you are just one of millions that come through. So, I mean, just think of it this way. You go into a casino and you lose just $1 in one day. They can look at it and say, well, we're going to have 1 million people come into our casinos throughout the world on any given day. So that amounts to $1 million that they're taking in per day just for your $1 loss, right? So generally people don't just lose $1 when they go to a casino, so you can already see how they make a killing off of this. All right, so but they don't need it to be very much in their favor in order to make a large profit. All right, that's why you see these large buildings. You know, you go to Vegas and you go down the strip and you can see these extravagant buildings with the decor that's just, you know, it costs a ton of money. Like how can they afford to have that? And then you also look at like the shopping galleries, like outside of the casinos, and every one of them's a high end. You know, you don't see an Old Navy or something like that. You see like the really expensive stuff, and you're like, well, who comes shopping here? Only the people who won in the casino, because now they have a ton of money that they can burn. The people who lost, they're trying to figure out how they're getting home. So that's a different story. So, game of roulette is a game that utilizes a spinning wheel and a ball. The ball is spun around the wheel and eventually falls in a slot. The the values on the wheel are also arranged on a board where the gambling takes place. And we're going to do an activity related to this, so you'll get a feel for it. The values span from 1 to 36, half of which are red and the other half are black. In addition, there are 2 green values, 0 and 00. Compute the expected value for betting red. All right, so we're going to either win or lose. They tell us in the problem that the payout odds are 1 to 1, right? So you do have to have a little bit of prior knowledge for this, and that is that you do get your wager back in games of chance at casinos, all right? So X, P of X, the probability of getting a red value is what will allow you to win the game, all right? Now, if it were just a deck of cards, the opposite of that would be probability of getting black, but here we're just going to say it's a probability that it's not red. All right. If I win, I'm going to win $1. I'm just making sure. Yeah, because they didn't give us a dollar amount, right? Yeah, so I'll just bet $1, and if I lose, I'm going to lose that $1. Right? As it turns out, I could have put any value I want in here. Right? If I want to put $1,000 for the wager and $1,000 for the win, I could have done that too. All right. So, how many reds are there? 18. So 18 out of 38. So the number of not red would be everything else. So 20 out of 38. All right, for whatever reason, I decided not to give myself room to actually do the calculation, so that sucks. Let me move some things around here. Learned this little trick recently. So I'm just gonna I'm moving it slightly closer, that's all. And I'll do my X times P of X over here. So 18 out of 38, negative 20 out of 38. So negative 2 out of 38. All right. We definitely want it in dollars and cents so we can conceptualize this. So to the nearest cent, what is negative 2 over 38?
A nickel.
A nickel, a cool nickel. So approximately negative 0.05. All right. So what we're looking at is for each $1 bet, in the long run, we stand to lose, or we expect to lose, $0.05. All right. So the purpose of me doing this is not so that you all walk out of here being like, all right, off to the casino. But you can see how, in the long run, it's more favorable to play this one casino game than it is to play that lottery. All right. The lottery is easier to do though, because all you're doing is picking a 3-digit number, paying $1 at a convenience store, and getting your ticket and just hoping for the best. All right. Here, there's a lot more involved. Also, a lot more potential for you to lose way more money than just $1. All right, because there's other considerations that come into play. One consideration is the fact that there are table minimums in casinos, so you can't just bet $1. All right, minimum at a table is generally in the $15 to $25 range. Right? It depends on the time of day though. So later in the evening, they up that. So sometimes it's 30, 50 bucks, something along those lines. All right. Also, there's a spin happening every couple of minutes. What's the likelihood that you're going to go to a casino and then just go to a game of chance, because whatever it is, roulette or otherwise, and just stay there for one spin of the wheel? You're probably going to do it a few times. All right, so not only is the minimum a lot larger than one, but you're probably going to do it for a bunch of different turns. Now, it's a 1-to-1 payout. All right, so you look at that and say, well, I have an almost 50-50 chance of winning here. All right, 50-50 would make it fair. They threw in, when they developed this game, they threw in the greens, the 0 and the 00, just to make the probability slightly in the favor of the house. All right, so your probability of winning by betting on red is almost 50-50, but not quite. All right, so what happens? People go to a table, they go there with, like, let's say $500. They're going to bet $50 per spin of the wheel. They figure, okay, I'll just do this 10 times, and if I lose, I'm out. All right, so they do it for their 10 times. They lose. A bunch of reds come up. They've been betting black the whole time. And on the 10th spin, they're like, well, I'm going to win for sure now. All right, because look at all those blacks that came up, or reds that came up. Probably going to be a black now. And then all of a sudden the green comes up and you're like, oh, all right, time to go home. All right, so it's just enough of a probability shift to make it in the favor of the house, but not noticeably so. All right, so yeah, it's still gambling. And when you're involved gambling, there's always chance involved. And even though the expected value is fairly nice, it doesn't mean it's an easy game to play. When you tackle the activity that I'm about to give out to you, you'll see just how intricate this game can be. Right. The one thing I'll have to do is I got to send out the file, because I printed out the game board.
It's not colored.
It looks great on my screen. The problem is it doesn't.
Can
Actually,
you just pull it up on that?
I could, but you know what? It just occurred to me. Now I have it on the back here. It's easier to see which ones are the blacks, and then you can just use process of elimination. So maybe I don't have to send out the file. So I'll give these out to you now. This is going to be due at the end of class tomorrow. It's actually fairly easy to complete, but you do have to learn a little bit about the trolley game, as we call it here, so that I can legally